In today's video, I'm going to walk you through how we test and select the optimal concentration that we use to stain markers on our mass cytometry panels. This ensures that we get an accurate signal for each antibody on our panel. I'm going to take you through 3 examples, starting with CD25, which is a surface marker included on our panels, Granzyme B, which is a cytoplasmic marker that we have on our panel, and lastly, I'll take you through an example for Tbet, which is an intra-nuclear marker. So for every antibody, we start with a similar process. We always start with a 6-point concentration series where we start at 6 micrograms per milliliter and perform a 2-fold dilution down to 0.1875 micrograms per milliliter to get 6 distinct concentrations that we test for each antibody. And at each concentration, we measure the median channel value, which is similar to median fluorescence intensity for flow cytometry. And we also measure the standard deviation of the channel values in both positive and negative cell populations. And this allows us to calculate what's called a staining index, which indicates the antibody concentration's ability to distinguish between positive and negative populations. And while the staining index is important, we also consider other factors when we're looking at the ideal concentration to use. So some of the things we look at are the visual separation between positive and negative populations in the gating. And we also look at the spillover into the +1, -1, and +16 channels. So the +1 channel is the isotope with a molecular weight that's 1 unit higher than the metal isotope that's bound to the antibody that we're testing. The -1, similar idea, refers to the isotope that's 1 unit lower. And then we also usually check the +16 channel to ensure that the metal hasn't oxidized. Lastly, we also look at the median channel value of the positive population at each concentration, and typically we're looking for a number between 0 to 100, ideally somewhere in the middle. And to give you a better idea of this process in practice, like I said, I'm going to walk you through 3 different examples of how we determine the optimal staining concentration for 3 antibodies on our panel. We'll start with CD25, which is a surface marker that's expressed on activated T cells and Tregs. Then Granzyme B, which is a cytoplasmic marker. It's expressed in cytotoxic CD8 positive T cells and also in natural killer cells. And lastly, we'll look at Tbet, which is an intra-nuclear marker, which is expressed on CD4 positive helper T cells. So starting off with our surface marker CD25, we started with calculating the staining index at each of the 6 concentrations. And looking across the staining index, you can see that they're all pretty similar across all of these concentrations. Although 0.1875 micrograms per milliliter had the highest one, we want to look at all the other factors since this isn't going to be a distinguishing feature. So the first thing that we looked at is the gating plots to see if there's a good visual separation, and also looking at the frequencies of Tregs in the positive gate, since CD25 is a marker that we're using to define Tregs. Looking at the Treg frequencies, you can see at the top 3 concentrations, the frequency looks pretty similar, and then there's a visual separation between the Treg population and the other cells. But then when you look at the lower concentrations, you can see that the Treg frequency starts to fluctuate a lot, and it's a little bit harder to get that separation between the Tregs and the other cells in gating, which indicates that gating Tregs at those lower concentrations might be challenging. And so to differentiate and help us to select the optimal concentration, we also wanted to look at the spillover, as I mentioned. And you can see here that there is minimal spillover at all of these concentrations, and there is no spillover at 1.5 micrograms per milliliter. Ultimately, that's the concentration that we selected for CD25 because it has a relatively high stain index, a low spillover, and also a good Treg separation, indicating that it'll be easy to gate Tregs. Next, we can take a look at Granzyme B, which is a cytoplasmic marker on our panels. And again, we start the same way, looking at the stain index at all 6 of these concentrations. And so you can see that 3 micrograms per milliliter has the highest stain index, although those top 4 concentrations are relatively similar. We also try to keep the median channel values between 0 and 100 for the positive population, and ideally somewhere in the middle so that all the markers are within a similar range. And above median channel values of 100, there's often a risk for spillover into other channels. So you can see at 6, at 3, and at 1.5 micrograms per milliliter, there's a median channel value higher than 100, which could indicate a risk for spillover into all those neighboring channels and also into the +16 channel. So looking at the bottom 3 concentrations, you can see that there was relatively low spillover, and also at this 0.375 micrograms per milliliter concentration, you can see that the MCV is right around 50, which is what we typically aim for. And so ultimately that's the concentration that we chose because it had the highest staining index at which we didn't see any spillover into neighboring channels, and also that ideal median channel value that we've been aiming for. Lastly, we looked at Tbet, which is an intranuclear marker. Again, starting the same way, calculating the staining index across all of these 6 concentrations. You can see that the stain index, while it's the highest at 0.75 micrograms per milliliter, all of them are relatively consistent across the concentrations. So we looked at our other metrics, starting with the frequencies of the Tbet positive and Tbet negative populations. You can see that these stay pretty consistent across the 3 highest concentrations that we looked at. We also looked at the MCVs here, and you can see that at 1.5 micrograms per milliliter, we have an MCV of 52.31, which is pretty close to 50, which is what, as I mentioned before, we're typically aiming for. We also checked for spillover into that +1, -1, and +16 channels just to make sure. As you can see, we did see some spillover at the 0.75 and 0.375 micrograms per milliliter concentration. Ultimately, we did select 1.5 micrograms per milliliter as the optimal concentration because it has a relatively high staining index. It also has a clear separation between those Tbet positive and Tbet negative populations that we'd be looking at. It has that 52 median channel value, which is what we're aiming for, and it also has very minimal spillover into neighboring channels. So that concludes our video on our antibody concentration verification process. If you want to read more, you can follow the link on the screen. That gives a more detailed article about our verification process. And for more videos about cytometry, feel free to subscribe to our YouTube channel. And thanks for watching.